My name is Debbie. I'm a strategic account manager here at Amazon Web Services, working with our digital native customers. And we are so glad to have you joining us today for this session about how one of our customers, Razer, a global lifestyle brand for gamers, built a modern data architecture on AWS. In this session, we will first address the challenge of data growth that many of our customers are facing. And then we will hear from Razer on their success story in turning this challenge into an opportunity for them to extract value from all this growing data by leveraging AWS analytics solutions. Data growth in itself is both an opportunity and a challenge. We hear from companies all the time that they are looking to extract more value from their data, but struggle to capture, store, and analyze all the data generated by today's modern and digital businesses. Here at AWS, our analytics solution aims to analyze all your data, achieve performance at scale, and provide easy analytics for everyone. Against this backdrop of increasing data volumes and the desire to get the right data to the right people, 2021 has shown us that we need to be prepared to deal with change. So what's happened over the last number of years? As customers have accumulated so much data, a lot of that data lives in different silos, which makes it really hard to do analytics. Customers are now looking for a highly scalable, available, secure, and flexible data store, or a data lake like Amazon S3 that can handle extremely large data sets. In addition to the data lake, they want to be able to run multiple purpose-built database and analytics services such as Amazon EMR and Amazon Redshift in order to ensure they have the right tool for the job. They also need to be able to move data between these systems with services such as AWS Glue, our serverless data integration service. In order to have unified governance across the data and services, customers can leverage our Amazon Lake Formation service. And finally, they need services that give them low cost without compromising performance or scale. We call this modern architecture for analytics the modern data architecture. Now let's dive in to look at who Razer is and how Razer went on its journey to modernize their data architecture. And now I will hand over to Hongjie, who is their big data lead.
Hi, I'm Hongjie, the big data lead at Razer. Let's start things off by introducing Razer. Razer is a global brand and we are the world's leading lifestyle brand for gamers. Our mission is to provide gaming needs by understanding what the gamer wants, hence, for gamers, by gamers. We are founded in 2005, currently listed on the Hong Kong Stock Exchange. There are currently 18 offices worldwide, and we have 2 headquarters, one in Irvine, California, another in Singapore. There are also key offices in Brazil, Hamburg, Turkey, Chengdu, Shenzhen, Shanghai, Korea, Hong Kong, Taipei, Thailand, Philippines, Malaysia, and Indonesia. At Razer, it's all about the ecosystem, which comprises of 3 key components: hardware, software, and services. We are the leader in gaming hardware, with approximately $1 billion in revenue in 2020. For software, we are one of the world's largest integrated gaming platforms, with Synapse, Chroma, Cortex, and many more, amounting to approximately 123 million registered users. For services, there are Gold, Silver, and FinTech, proving out a service model of about $128 million. To serve the data needs of our Razer ecosystem, we need to design a purpose-built data architecture. In doing so, requirement gathering is a critical first step. A data flow from data producer to big data team to the data consumer has a set of operational requirements at every stage. At the data producer stage, it is important to know things such as the data source type, whether it's a data stream, such as software application clickstream data, a database, like a storage database, API call, or raw file, the data ingestion rate required, and the monetary cost. Once the data reaches big data team, a good understanding of the domain is required, which comprises of things like the size of data set, its data type, and the data fields needed. This understanding is required to perform the different operations at big data. After this stage, understanding the requirements of the data consumer, such as our business stakeholders and product developers, is necessary. Data recency, refresh rate, the analytical needs, and the cost are requirements necessary to be considered. These are translated to the type of tools to choose for the data consumer, from monitoring to visualization tools. After gathering the requirements, the next step is to understand the functions of the various AWS services and tasks they are designed to perform. Starting with data input, if the data source is streaming, we have selected a combination of Amazon Kinesis and Kinesis Firehose. If the source data is accessible via API calls, which could also be a scheduled job, Glue would be a good choice. For direct database connection and query for scheduled data ingestion, Data Pipeline would be a great AWS service to serve this purpose. For data output, Redshift is the preferred data warehouse solution if it's a small-scale data storage which is queried frequently. Amazon S3 will be the ideal choice for large data storage which are queried lesser. Moving on to data processing, for event-based trigger like Amazon S3 object put event, a combination of AWS services was chosen. The event triggered is captured by AWS Lambda, which can be attached to an Amazon ECS if a larger processing power is needed. After the first stage of processing, this data is then stored as Amazon S3 objects. If further processing is required, which could be dependent on the full day's data event, Amazon EMR is the selected service to help in the large dataset computation, and the output of this computation is stored once again as Amazon S3 objects. At this stage, Amazon Athena or Redshift Spectrum can be used to query the content of the Amazon S3 object for further aggregation used in reporting. With the knowledge on both operational requirements and selection criteria for different AWS services, we are ready to apply it on a use case. The selected use case today is on the building of a data lake and data warehouse where arbitrary numbers will be used for illustration. In this scenario, the source data is an application click stream with 2,000 records per second. On big data end, this translates to 350 gigabytes of data per day, comprising of 500 million rows and 5 columns, with additional data transformation required via external libraries. For the data consumer, a data report is required, which are aggregated values computed daily for data up to 3 years ago. These numbers need to be viewed on the fly. For such a use case, Amazon Kinesis and Kinesis Firehose are selected to ingest the streaming data. As these are event triggers, AWS Lambda is used to process the Kinesis Firehose output file, which can be further processed using Amazon ECS. Amazon EMR is then used after the initial processing for further computation, before Athena is called upon to perform the calculation for the daily report, then storing it in Amazon Redshift. Everything before Redshift are AWS services forming the data lake, while Amazon Redshift is the data warehouse. With the different operational requirements, selection criteria, and use case presented, let's summarize the key takeaways for Razer. Before embarking on any purpose-built data architecture journey, it's important to have a good in-depth understanding to appropriately address the operational needs and also to understand the capabilities and functions of the various AWS services. Only then can the most applicable AWS services be selected to design a purpose-built, customizable data architecture. I shall now hand the time over to Debbie once again to talk about the latest AWS services.
Thanks, Hongjie. Speaking of selecting the most appropriate AWS services, at reInvent last year, we launched a number of new services and features that continue to accelerate innovation across our portfolio to help customers build a modern cloud data platform. One of the newly launched features is the serverless option of Amazon Redshift that makes it easy to run and scale analytics in seconds without the need to set up and manage data warehouse infrastructure. With Amazon Redshift Serverless, any types of data users can get insights in seconds by simply loading and querying data in the data warehouse. And with new features like this, we are excited to continue supporting Razer and all our other customers to further modernize their data architecture. We have now come to the end of the session. Thank you again for attending. We hope you found the session helpful. In order to gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. You can also validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. We really appreciate your feedback, so please do take the time to fill out our survey and let us know what you think. We hope to see you again at our next summit.